I think I'm audible to you all. Right. Okay. Okay. The live stream has started. Okay. So this is the first live stream on system design concepts. Right. So we'll be going with the basics, just the basics today. So the basics, which means, right, what is the system design and also why we use this concept, why we need to learn this concept in software development. Let me tell you first, what is like the system design, right? Let me tell you the first thing is if I somehow draw a car like this, which is having something like this, and here, and there are wheels here, and then a wheel here, and I would place something like, wait a second, something like this, right? So I say that this will be a car model which would be built by me, right? This is the car model, right? Which is built by me. I know it is not right, right? Okay. So, but this is what it looks like. This is just a blueprint. Now, the first concept which I want to tell you is this is just the outer part. It doesn't know the brakes in, it doesn't know what is the engine, it is the V8 engine or V12 engine. It doesn't know the output and also uh, you see the horsepower in it and also the mileage which it will give for a liter of petrol or diesel, right? So what, how the brakes will be, and also the engine, what will be the output, like how horsepower and also the mileage, and what are the lights which we'll be using. That's not a case, and also the tires, and there are many things which we go on by when we go with the making of a car, right? Just think it as, you see, when a driver is present in this car, he doesn't know and he doesn't bother about what is there in the internal function, how the brakes are connected, and also the gear system, and also the doors, and also the sunroof, everything, every mechanism. He doesn't know. He doesn't know. He doesn't know the internal structure, and also the functions and mechanism in it. The driver doesn't know about the functions and also the mechanism of every part and every detail of a car, right? So now let us stop here. What does this mean? He doesn't know the internal structure and also the functions and mechanism, right? When we are using the Instagram app, does we know about how does it increments the likes, how does it goes with the follow request and also the post and all, does it goes like this, right? Do we actually know all of this stuff, right? Do we actually know this? No. This thing hiding something, right? Hiding unnecessary necessary data from the clients or users is called as abstraction, right? A data abstraction or something like that. That means we don't need to tell every user how does this works, or how does this functions in the app, or also something else which we will be implementing. But let's come with the next concept which I want to tell you is, right, what, what is the system design itself? Let me tell you the clear definition what it is, right? So it is nothing but how do we build how do we build software so that people really really uses it, right, without any issues, right? So it is something like, let me tell you, if I am having something like an imaginary 3D diagram of a burger, right? So I have made with a 3D printing machine, I made a burger, right? That's how the components will be, right? Nothing but the components. Let's go with the components in few minutes. But I made a 3D printing with a 3D printing machine. I made a burger. But is that burger eatable? Is that burger eatable? No. Why? Because this is just a 3D printed burger and it can't be eatable. So to make that eatable, we need to go with the actual ingredients, which is nothing but a bun or a bread, right? And also some vegetables and also some, butter, I think. Butter, not butter, it is cheese and all these things, right? So these are some things which I need to get it and make it so that people actually uses it. Now, the same thing, we might have an idea of an app or a website. We just need to design it, right? Design it. Let me tell you how designing is important while building apps. Let me tell you, imagine, just imagine you built an app and that app can only only go or handle 10 user requests per second, but the app is used by 1000 people and has 1000 requests for 1 second. Now, this case, can I know in comments what or the live chart, what does this case actually mean? So you built an app and that app can only go with or handle 10 user requests per second. But the app is used by 1000 people and has 1000 requests per second, even if it is something like authentication or authorization, something like that. Let me know in the live chat what does this scenario is called, right? So you built an app and that app can only handle 10 users requests, but here it is something like 1000 user requests, right? It is way more than the request which we have developed our app. So this scenario is called load, right? So which is nothing but you have made the app for only less user request, but it has went to the 1000 people, right? So 1000 people acting or requesting your app for some functionality like login, or also log out, or if that app is a social media app, a refresh or something like that. So this load might be 10 for some apps, some small apps, then it can go to 1000 or even 10,000, and it can also go to 1 million, which is nothing but we need to we need to we need to scale our app according to the demand, or something like the request. Now there will be sometimes the login request will be more like more than usual from 9 to 9:15 p.m. for any app like for Instagram. Now this Instagram will be having many servers. But before going with many servers, what does this servers mean? Let us come back with this problem where I was having the app built for only 10 user requests per second. Then the app is used by 1000 people, and also the requests are 1000, which is way more than 100 times more than the request for which the app was built. Now this I named it as the load. What is the load, and how do I balance it? How do I balance this load? Sometimes the login request will be more than usual from 9 to 9:15 p.m. for Instagram, where most of the people will be uh, after the work, or and also after the college, right? So it will be more at that time. For that, I am saying that we need many servers. But before that, let us come again. What is a server? What is a server? That's what. So the server will be nothing but the APIs, which will be having something like APIs, and also many things which will connect client client and server will be connected by the APIs. This server will act as, getting the request from the client and giving the response. Let me tell you, here you have a restaurant. Wait a second. We are having a restaurant, right? You are a customer, and there is some waiter here, and there is the kitchen. Now the first thing, the customer can't go to the kitchen. I'll tell you why. So if customer is allowed to the kitchen, he might end up taking more quantity of food or more quantity of beverages or anything with low prices, right? So that's what comes with the mobile or the client, and also the storage or the data. The mobile is not directly connected or directly uh, you know contract between the mobile and also the storage for any app. It is very dangerous. I'll tell you why it is very dangerous. As I said, if the customer is allowed to the kitchen directly, he will end up taking much than he paid for, right? Now there is someone in the middle who we call them as a waiter. Now the waiter takes a request from the customer, takes a request from the customer, goes to the kitchen and gets that beverage, anything, a food item to the customer. So the kitchen gives the response, gives the response. He takes the response back to the customer, right? So how can we align this with the system design, right? So this is a web app. Now here, instead of customer, we have a client, which can be a mobile app or any website. Now the waiter is nothing but application program interface, and the kitchen is nothing but the server. Server will handle the data and the storage, everything, right? So the client request API, the same request is sent to the server, right? But there is one thing which the API stops. I'll tell you why it stops, right? So when API goes to server, goes to server with a request, with a request of a client, of a client, the server checks. Then here, the server checks whether the client is authorized. That's the first thing which it will check. And the second thing, these are just the basics of what are the checks that will be done for any server. Will be going, if you have new about the web development, you might be knowing the 404, nothing but 404 error, and also get post method, which are some of the requests which will be sending from the client, right? So these are some of the requests. I'll tell you deeply when I explain about the Node.js, right? So the server checks whether the client is authorized or not. If he is not authorized, then it will send an error. It will throw an error. Now, again, the server checks whether the request is correct. I'll tell you what does that mean. Whether the request is valid or not. Let me tell you. Imagine this is a pure veg restaurant, right? But this customer has, you know, ordered something like a non-veg item. If this request was sent to the kitchen, this kitchen will deny the request to the customer, right? So that's the simple example which I can tell you. When this will happen, when uh, client client asks for a request that isn't valid, isn't valid or not present at all, right? So this is a broader, you know, something like a simple concept or the basic concept of how to the API work, and also what is a load. Now, if you see, imagine the customer or the client having having sent only one request, and the server delivered it perfectly or responded it perfectly. Request, request, and then response. Right? Now, let us come again. Imagine the client is having ordered, or let's come here. He ordered 500 burgers, right? If he ordered 500 burgers, this kitchen or this waiter, right, might get in the load. right? The kitchen might get in the load of making 500 burgers. That's the same way the client wants to upload or do something, upload 1 GB, 1 gigabyte of data. That's huge for a server, right? Now, now, let me tell you one thing. If there are many clients, client 1, client 2, client 3, and also client 4, and many clients like this, what will be their client 1 million? There are 1 million clients for only one server. It is not even possible, and we cannot even think about that. Within 100 to 200 request, continuous request, the server will break down and the app will totally crash, right? So for that, let me tell you the example by taking Instagram. How does, just imagine if Instagram has only one server. This is nothing but a hypothetical question. Instagram will not have only one server. Let me tell you why. Every second there will be thousands of requests, thousands of requests per second. What does the request actually mean? Here the request actually mean something like upload or delete your post, like, comment, and then share, and also save. There are many requests like this. Log in and then log out, and also chart, and also upload story, and everything come under upload, right? And is there anything which I am missing, like, comment, share, everything? These all are the request per second. There are many millions of users using Instagram. So for that, there will be not only one server for Instagram. There will be thousands of servers, thousands of servers for Instagram, right? So that's how a broader concept of how does this all system design concepts work. Now, by using these thousands of servers, the Instagram handle millions of users and their request. Now, imagine, imagine you have only uh, three servers. Imagine you have three servers, S1, S2, and S3. There are something like 20 requests. Request 1, request 2, request 3, request 4, till request 20, right? Let me name it as right. Okay. There are 20 requests and you have only three servers. There will be some API behind in between this, but we are not gonna talk about API in between. Let us talk about let us talk about load balancer. Imagine this server is already working. Wait, so it is already working on two requests. Then I got a request 3. Then this load balancer, what it will do is it will not assign this request to the server 1, it will go and assign it to server 2. Then we got request 4, it will not assign to server 1 or even server 2, it will assign that to server 4, which will be called as load balancer. That's how the load is balanced between different servers, right? So that we don't get nothing but it is a thing which is called as balancing the load, and also more load on any server which will result as in crash of the system, right? Now, let me tell you, you need to have RCSQ to understand this system design. R is nothing but reliable, C is nothing but the cost, as 3S, right? 3S, simplicity, simplicity, and also scalability, simplicity, and then scalability. If anyone is having any doubts, please let me know in the comment section, right? Simplicity, scalability, and speed. Those are the 3S in the RCSQ, right? What does the reliable actually mean? Let me know in the comment section. What does reliable actually mean to you in system design, right? Let me tell you with something like a simple example. You know, what if in a simple car, in a car, in a car, there are two scenarios: wipers, wipers not working, not working, and brakes failed. In these two, which is more dangerous and which affects the car more? Let me know in the comment section. Which will affect the car much, right? Does wipers not working in a sunny day, right? Uh, in summer season, in a summer season, wipers are not working. That's the case. And the second case is failing of brakes. From these two, which is much effective, which affects the car much? Let me know in the comments, right? So the brakes failed will affect the car much. In the same way, what happens? What happens if something fails? Something fails, right? This is the most important thing. Why? Because if data storage, or if the database is failed, if it is failed for something, for some time, if the database or the storage is failed, then for some systems, there are two systems: read heavy, write heavy. I'll tell you what is read heavy and also what is write heavy. So in a car, if the brakes failed, what will be uh, the things? But what happens if something fails? Something like a storage, the data or the data storage is failed. At the time, it depends on the system, right? Let me tell you how does that system works. If something like, let me tell you, in the Instagram itself, if the data storage is failed, then you can't log in into the Instagram. That's the first thing. Why? Because the login comes from the credentials which is stored in the data storage. That's the first thing which you cannot do, login. And the second thing, you cannot refresh the page, the feeds page, or also the reels page, and get the new reels or new post from uh, your following people, right? Anyone, right? You cannot get it. Why? Because you cannot even upload it, and even the uploaded data cannot be retrieved. but the data only which can be retrieved is cache. I think it is called a cache data. I don't know how to pronounce it, but the cache data can also be retrieved if the data storage or database is failed. So the cache is nothing but a backup data, something like which is uh, the data which is requested for many times. Let me tell you how does the thing works. Like if you are going with accessing the data of your attendance, right? I don't know whether they use the cache or not, but if it is cache data, if something like if you are asking the website or the mobile app for your attendance or something like watching a YouTube video or something like even in Spotify, which is having a backup songs which you listen it, right? So that is something like a cache data. Even if the data storage or the data is failed, the data system is failed in the app, there will be some data which you can access, but not everything. You cannot upload. Let's come again to the Instagram login. You cannot log in. You cannot refresh the page. Even if you refresh it, you'll get the same things which you just viewed. And the third thing, only cache data will be available. You cannot upload anything. Why? Because if you upload it, it should be maintained or it should be transferred to the data storage, but the data storage isn't working, right? So it depends on the impact on what the app will be crashed or it can be run for some minutes and we can fix it, right? Now, how much will it take? How much to build? That's it. And let me tell you how this simplicity is. You take a car. If the driver, if it's for the car driver, it might be after the driving or taking training from his school driving school, it might be easy for him for getting into a car and driving a car. But if this driver is put if we put him in a plane, right? If we put him in a plane and say him, you are the pilot and you need to ride this or fly this plane, he he can't even understand what is there in the plane. What is the I think it's the dashboard. He cannot understand it. So we need to make apps simple enough so that people easily understands, right? So yeah, that's the third thing. And what about the scalability? Let me tell you, if your app starts with 10 members and then it goes to 10,000 members, then it might go to 1 million users. This scalability, right? You made the app, you made the app for 10 users, and then you made it for, if 10,000 users are using your app, then those 10,000 users should be having no problem with your app, with your app login, and also retrieving the data and also credentials and everything. They should not feel hard or difficult to access the data. I'll tell you, if 10 users are having if 10 users are having request on your app, it is very, very low. But if 10,000 users, it is a load. But if 1 million users it is a very high load on the servers. And speed. There are two things, right? The speed and also the accuracy or the precision, right? Now, there will be something like, let me tell you, there is an Instagram post, right? Here, there is an Instagram post. There are the number of likes at that moment are 71. Don't bother about the comments on and the number of shares. There are 71. Now, you want to have, you know, there are two friends, you and some other friends. Let me remove this for some time. Wait, let me remove that for some time. Now, you and your friend having the same, let us take a name. Let me tell you who is, I don't know, who's Mahesh Babu. Okay, Mahesh Babu. Let's take his name, right? Now, you and also your friend, you, it's your account and it's his account. Now, you both of you hit the like button at the same time. Now, only one like 72 here and 72 here are updated. Only one time got updated. But you liked it once and your friend liked it once. It should be two likes increment. But this doesn't matter in social media. But in transactions, in bank transactions, it matters a lot. The accuracy, or we can say it as consistency, atomicity, consistency, consistent, and all, right? So, how speed is your system, is your app or website? No. So this, I said, this doesn't matter. The social media doesn't matter how much, how much like your post got or how much likes does it got. But let's come back. Where does where does accuracy accuracy actually matters? Let me tell you. Here it is you, right? Let's name you as person A, and there is another your friend itself. Your friend itself who is having who is named as P, right? You go to a bank, you go to a bank, then you deposit, sorry, you withdraw 10,000 rupees. Now, this person goes to another bank, the same bank, and right now he deposits 10,000 to person A. Let me tell you the naive approach which will be failed. So, what happens to person A? What happens to person B? So, the initial balance, we are only acting upon only one bank account. Initial balance of person A is 50,000, right? So, first, person A checks balance, checks balance. So it will be 50,000 and he withdraws Then what will be the balance now? 40,000. Now these two are having these two scenarios, or these two events are happening simultaneously at the very same second. Now person P, let's come to person P. He reads balance 50,000, 50,000 and deposits 10,000, right? So after deposit he will get, wait, sorry, after deposit he will get the balance as 60,000, 60,000. But if you see, from 50,000, deposit 10,000 and withdraw 10,000. But by doing it, deposit is nothing but plus, withdraw is nothing but minus, which will give me just 50,000. But if you see, both of them got the wrong values, 40,000, 60,000, right? What does this 40,000 mean? 40,000 means undervalue, and then 60,000 means more amount, right? This is just a pure error. For that, banks solve this problem, solve this by, how do they solve this problem? Atomicity, atomicity and locking. Let us talk about the atomicity first. Atomicity is nothing but either everything happens, everything happens, or nothing happen, nothing happens. Let me tell you with an example. So first, checks balance, checks balance, then withdraws, withdraws, then account, let's say that as account row, uh, lock, let us say that as a lock itself, account row lock. Now withdraw successful, withdraw successful, successful, and then commit. If anything fails, if anything fails, then roll back. What does this roll back mean? It will roll back to the first balance which I have, which is nothing but 50,000, right? If you know account was locked in the withdraw, you have selected the option of withdraw and account was locked, nothing but no other person can do the transaction on your account. And instead of the withdrawal successful, there was a power cut in the ATM. Then roll back to where? To the very previous step, first step. Now, what is this locking? If person A making transaction to account A until the transaction is either successful, either successful or failed, the account is locked from other transactions, other transactions. Let me tell you how does this works. First, we will be withdrawing, right? So withdraw, lock, withdraw 10,000, 10,000, then commit. What is the balance now? Balance available is 40,000. Now, after that, he is person A and he is person B. He will deposit, here also lock, Here will be will free the lock. Then here we will lock deposit 10,000, commit. Now what is the balance? 50,000. The last balance, last balance is what we expected, 50,000, right? I think you got it. And if you have any doubts, please let me know. Till here, banks solve this by atomicity and locking. Let me know in the live chat. Do you have any doubts? Yeah, this is the today's session. If you have any doubts about the DSA and also the system design and even about jobs and placements, please let me know in the live chat. And here is my LinkedIn account. And also let me share you the Instagram, as we have took the Instagram name for these many times. In Insta, I am having the name as underscore R underscore S underscore S double one. What about the LinkedIn? I'm having this. Wait a second. Yes, LinkedIn. You can find me by linkedin.com r sai sidhu, right? That's my profile link. You can go and just, is there anything? No, I think no. From there, you can go to threads from Instagram. Yes, so if you have any doubts, please let me know in the live chat. So initial balance RCS cube. Yes, we'll be ending this session at 10:10 exactly. So if you have any doubts, please let me know without any hesitation. So yes, if you have any doubts, please let me know in the comment section. We'll be ending this session in 3 minutes.